Hello and welcome to Alyssa's Fabrication Workshop. Today I'm going to be showing you countersinking. What is it, why do we use it, and when do we use it? These are some questions that I'm going to help you answer. In my hand, I have a piece of aluminum with a hole drilled through it. As you can see, if I were to want to put this screw through this hole, it's sticking out of the top a little bit. If I run my finger across it, it sort of gets caught and it feels uncomfortable. We have this thing called the ruler test, where you can take a ruler, run it across the surface of your material, and oh, it gets stuck. That means we need a countersink. So here in my drill, I have a countersink stuck into the top right here. If you notice, at the tip of the countersink, there is this angle. How this works is that as you push in, it'll remove the material in a diagonal fashion, opening up the surface to be a wider diameter to accommodate the screw that you're using. The first step that we're going to do is we are going to clamp our material to our workbench. Next, you want to make sure that your drill is plugged in and rotating in the correct direction. That looks right to me. Okay, so we're first just going to start out slow and steady. We don't want to drill too deep too fast. Now we're going to check if we've gone deep enough or if we need to drill a little bit deeper. So a quick way to test is actually to get your screw, turn it upside down, and place it over top of your hole. It looks to me like the diameter of my screw is a little bit larger than the diameter of the hole I've drilled. So I'm going to keep drilling a little bit deeper. That looks good. Wow, that sinks nice and flush. If I take a ruler and run it across, it doesn't even get stuck. And that is how you countersink. This right here is a rivet. As you can see, there's a thick part and there's a thin part. The thin part is longer than the thick part. The thick part is the fastener and the thin part is the stem. How a rivet works is you place the stem into this handy dandy rivet gun, and the gun will actually pull the stem, and there's a little head on the other end near the fastener. As you pull on the stem, the head will go through the fastener, expanding that material around the hole that you place it into, which causes the two materials to fasten together. Today I'm going to be showing you how to use it. The first thing that you're going to do is place the stem into your rivet gun. There's a fitting that the stem goes into, but if this fitting isn't the right size, then you can replace it with one of these by unscrewing it and then screwing in the correct size with this tool. You just place it over the hexagon and you can twist it to unscrew it. Once you have the rivet stem in your rivet gun, you can just squeeze this together, and as you can see, the material is starting to deform. You want to keep squeezing it until you hear a popping sound, and that's how you know it's done. That's why it's called a pop rivet. So now I'm going to show you how to do it on these two materials so that you can fasten them together. When you rivet two materials together, we do consider it to be a permanent fixture. So only do this when you're sure that you want these two materials to be joined together. There is a way to unrivet something by drilling a hole through the finished rivet, but it does typically ruin the materials you're working with, so you want to avoid doing that at all costs. So as you can see, I placed the thick fastener side through the two materials that I want to bind. Now I'm going to place the long stem part into the tip of my rivet gun. Now I'm going to keep squeezing until I hear a popping sound. That's how you know it's done. Okay, so here is my binded materials. As you can see, the rivet has gone through both sides. They're securely fastened together. And you can see where the tip got threaded through the rivet fastener side. Next thing you want to do is make sure the stem falls out the other end. If it doesn't immediately do that, you can twist this back and forth and it'll work. Okay. With me on my workstation today, I have the piece of sheet metal I would like to bend, a fine-tipped Sharpie marker, a lovely ball peen hammer, my handy-dandy calipers, and a vise with the protectors in. The first thing that I'm going to do is measure out where I would like the bend to occur. Using my calipers, I have pre-measured 1.5 inches, and I'll measure that on my piece. Now I want to make sure that I don't scrape the piece with the calipers because this will actually weaken the joint. What I'm going to do instead is use my Sharpie marker to gently make a mark showing me where I'd like the bend to occur. The next thing that I'm going to do is take my piece of sheet metal and place it in the vise with the protectors on. I want to make sure that the line that I marked earlier is at the top, right on the edge of these vise protectors. The first thing that I'm going to do is use my fingers to gently bend back the piece of sheet metal. Once this looks good, I'm going to take my ball peen hammer and gently hammer across this corner to get a nice crisp crease. This looks pretty good. Hello! So today I'm going to be talking about self-tapping screws. So this is an example of a self-tapping wood screw. As you can see, there's a tiny point on the tip of the screw. This operates as a blade for the screw. So as you're drilling it into your piece of wood, it is removing the material for you so that you don't have to previously drill anything in most cases. By contrast, this is an example of a machine screw. Notice how the tip, there isn't that blade, it's just flat. In this case, you would need to previously drill a hole and pre-tap it in order to achieve the same effect as the self-tapping screw. So self-tapping screws are your friend and they make your life a lot easier. This is an example of a driver bit. It's exactly the same as a screwdriver tip, as you can see here, except instead of screwdriving it with your hand, you can actually place it into a drill and have the drill do the work for you. So in today's video, I'm going to be attaching this piece of sheet metal to this wood block. The first thing that I'm doing is clamping them together into my workstation. Next, we are going to place our screw in our drill bit, place it on the material, and carefully and slowly drill your screw into your material. If you do it too fast and too hard at the beginning, you can increase your chances of splitting the wood. As you can see, these two materials are nicely fastened together. With me today, I have two pieces of wood that I'll be gluing together. Titebond Premium 2 wood glue and a clamp. How wood gluing works is very simple. You really don't need a lot of it, but essentially you're just going to drag it over top of your wood. And you want to make sure it's nice and even and smooth. Think like butter, not like cream cheese. Next, I'm going to be taking my other piece of wood, lining it up to how I want them to be glued. And then I'm going to take my nice handy-dandy clamp and squeeze them together. As you notice, some of the glue falls out of the edges. To solve this, we can take a damp paper towel and run it across the edge to get a nice smooth surface. We're gonna let that sit and dry.
20 minutes later.
Oh look, it's done drying. You can't take it apart. Nice and sturdy. And it is also food safe, so you can make cutting boards with it, but please don't eat it in class. Pilot holes are really important if you want to not split your wood when you're trying to drill a screw through it. So right here I have an example of a time that I didn't use a pilot hole, and unfortunately you can see the wood did indeed split. So today we're going to be installing a pilot hole first and then drilling our screw in. So how do you decide what size pilot hole you need? Well, lucky for us, we have our handy dandy gauge it right here. At the top you can see that there's a lot of numbers. Well, this is a number 6 screw, so I'm going to stick it in the hole that says 6. Above this hole, there are 4 numbers listed. There is the softwood pilot hole screw, and the hardwood pilot hole screw, and 2 others that aren't important for us right now. We're going to be focusing on the hardwood pilot hole screw size. So, it tells us we need a 5/64 drill bit. I have a drill right here with a 5/64 drill bit. So we're going to go ahead and use this and drill into our piece of wood. And there we go. That's our pilot hole. Now we can go ahead and take our screw and put it into the wood. To do this, we are going to replace our drill bit with the appropriate driver. Today I'm using a P2. We're going to go ahead and line up our screw with the hole that we just made.
Yeah, that's what I was trying to figure out how to do it like that. Thank you.
Yeah, I would just do like comma as I.
And there we go. The wood didn't even split. Our screw is installed and we're good to go.